Hello friends, myself Shriram Korde. Now let's spend some time about understanding data types. The reason to create this video is because many times we use int x, int y. That means by default typically people are habituated to using integers. Then we have character, then we have float, then we have double, then we have short as well as we have long. So now the question is which data type should be used? So how do I basically decide? And that's really the question. That means like I can have say character, I can have integer, then I can have say short, I can have say long. Then in long there are some more things, so we'll talk about it little later. Then you have float, and then essentially you have also double. Now when we are dealing with this, then as part of say integer or as part of say float, then you also have signed as well as unsigned. Similarly with respect to characters. That means now when we are talking about these data types, we also need to consider signed or unsigned. Signed or unsigned is what typically we need to consider for each of these. So basically which thing in C language will help me this, because otherwise I don't understand what exactly when I say integer or when I say short. So now I have told you in our earlier videos, like when we say int x, then essentially x is the name of a location, and when I say location, that means few bytes are reserved. So how do I decide how many bytes are reserved? So the key question is the bytes that gets reserved. Okay, so that is very important. That's a question. So how do I know that? How many bytes basically will get reserved when I use these data types? Like when I say character, then how many bytes? Similarly, when I say integer, how many bytes and things like that. So in C, there is a nice operator, and please note what I am saying. It's an operator which is called as size of operator. Many times people think, is it a function? No, it's not a function. Essentially, it is called as operator. So using this size of operator, so it's a, though it looks like a function call, but essentially it's a size of operator. So using this size of operator, you can get the size of bytes that basically gets allocated when you declare a variable as a character or integer or short or a float and things like that. So how do I basically do this? So let's write a simple code, and so that we know how typically this can be done. Okay. So let's now let me just open code, and here yeah, so I think I have the code open. Okay. So here you can see there is a empty file. Now I can have a variable that I can declare say character ch, and then I can probably initialize it to say capital A or B or whatever. Okay. Now if I want to know how many bytes gets reserved when I say character ch, then I can make use of basically the size of operator. So that's the important thing. So essentially what we are learning is use of size of operator, and for obviously for various data types. Okay, so we focus is obviously data types. So when we have character ch is equal to a, that means how do I know that how many bytes are reserved? So I can always do that by doing say printf. That's the easiest way. You can always put breakpoint and things like that, and can put a watch and all that. But a very easy way to do that is character, and I can simply say size, and then you can have here get it printed that size. So I can have it here, and then comma. And now you will see I am using this size of operator. So this is that size of operator, and then here I will simply pass ch. That is the name of the variable. Okay. And now if I basically run this code, then you will see it's going to give us that. So here it's going to tell character size is 1. That means it has basically occupied 1 byte. Okay. Now, is it required that I have to basically have a variable and then initialize it? Need not be. Why? Because essentially what you are interested in, when you have a variable which is declared as data type character, how much of space essentially gets reserved, and because ch is just a name that anyway now we know. So I can always do this thing similarly. I can do it like this. So printf character size, instead of doing ch, because ch is the name of the variable, you can simply say size. You can simply say here size of char. That means it's actually the data type. Okay, directly data type. That means it is going to tell when I say int, when I say char, how many basically bytes get reserved. Okay, so that's the important learning that I'm trying to tell you. Okay, so if I now run, okay, if I now run, so you will see here character size 1 has come, that is for the first printf. For the second printf again it has printed 1. Why? Because size of char, essentially we are now understanding how many bytes get reserved when I use this keyword character. Okay, so similarly I can have I can do it for, say I'll do it here for printf. So instead of that now I can have say short, because there is a data type short, so I will simply say size of short. Okay, then I can basically do it here size of int. So I'll just put here integer int. Okay, and then there is a long also. Let me just put it properly, this message, then long size. Okay, so now we can get it. Then there is long also. It is very interesting. So in case you require more space, then you can always have long. Okay, that means here I could have done here like this short, say s. I need not initialize it, because when I say short s, it's going to allocate some amounts of bytes in the memory. Okay, similarly I can have here say integer I, then I can have long L, and I can have long say LL. I'm just giving the name of variable LL. Okay, and now if I run this thing, if I just run this code, so you can see this now. Very easily we can see. Yeah, so character size, as I already showed you, character size 1, again I have done using the actual keyword char. Then similarly for short it is 2. Now you can see when I say short s, that means 2 bytes will get allocated. Okay, then when I say integer I or integer any x or whatever, so then integer is essentially going to allocate 4 bytes will get allocated. Then long is going to get 4, and then long, that is what I told you here, long. Okay, so here this is long, and if I just run it, then you can say long size is 8. Okay, that means 8 bytes will get reserved. So now who is deciding this, how many bytes will get reserved? Okay, I can always use here, instead of short I could have simply use s. Okay, doesn't matter. Okay, because many people otherwise will get confused. So you are doing it just on the name of the keyword. Okay, so you will see short is essentially 2. That is what here I have used now s, that is the name of variable. So it doesn't matter whether you use the keyword directly, that means of the data type, or whether you use the variable name, it doesn't matter. Okay, so now the question is, who is doing that? So essentially this is decided by the compiler. This is decided by the compiler. The C compiler, what we have here, it is CL compiler, or if it is, say for some people who are using say GNU C compiler, like that, whichever the C compiler, here it is a Microsoft C compiler, which is cl.exe, which is used as part of building this code. So essentially this compiler is going to decide how many bytes basically get reserved. So now we can basically just do it for say 2 more things. So let me just do it here. So that is for float, and we can do it for double. So double size, float size. So here we will say float, and here I will have double. Because I told you now we can just use this and we don't require a variable to be declared. Why? Because the moment you use keyword that and then the name of the variable, those many bytes get reserved. So let me just run this code now. So now you can see float is 4 and double is 8. That means long size also is 8 bytes and double size is also 8 bytes. That means when you say double D or whatever, that means now it's going to occupy 8 bytes. So now what is the learning from this experiment or this particular thing that we are trying to do? The learning is very important. The first thing is that don't generally try to use long or integer or use it, or even for that matter long line. If in case you know that your whatever the data that you are going to feed, it is enough, 2 bytes are enough, that means the 2 bytes range is enough, then I can basically use short instead of using it integer, or say for that matter long. Similarly, we can simply use float because it's going to occupy, one float is going to occupy 4 bytes and double is going to occupy 8 bytes. So the thing is, it depends on your requirement and accordingly you choose. Similarly, when it comes to signed and unsigned, now signed and unsigned is a little tricky. The reason is, like, suppose if you are using it say character, and you are not going to deal with any negative value, then you just simply use unsigned. Otherwise, you can by default it is signed. So that's why you never use the keyword here. Okay, but in case you want to have say signed integer or unsigned integer, because by default it is signed. So if I just want to do unsigned, then I can use unsigned and then I can say unsigned int and say, let me just say unsigned int x. Okay, so whether it is signed or unsigned, it's going to occupy whatever the int size it's going to take. Okay, so I could just do it here for the sake of completeness. So I will just print here once again, and here I will just say un and then unsigned and just putting short, and then here I will say unsigned int. Okay, and let me now run this code. So you will see unsigned int is still 4. That means int size is also 4, unsigned int is 4. So what exactly happens is only the last bit of the 4 bytes or are allocated, that essentially will deal with, either you want to deal it with positive number and negative number, or you just want to deal it with unsigned. That means all numbers will be positive. So when you basically are using signed or unsigned, you need to be careful, or you need to know that for what purpose you are doing, and accordingly you do that. Because if you use unsigned, then obviously you can store more length. That means because you get one more bit. Okay, so now when I'm telling you all this, you may get confused, what is this I'm trying to tell you. So probably I will just show you a slide and that will give you a nice idea. Okay, so here you can simply take a look at it. So if it is a by default, I told you it is a signed char. So when you say simply char, that means it's a sign. Okay, so let me just pull this out. Okay, so when you say simply char, then by default it is signed. So it is going to take minus 128 to plus 127. If you just say unsigned char, then it's going to have 0 to 255. That means if you are enough range is 0 to 255, your job is done, then you don't require that. And obviously you know the formatter that you typically will use is a %c. Now this thing is specific to that particular compiler, so we did not really follow this. Why? Because it's part of some ready-made table, but you can check by doing size of, as essentially this is the bytes. Okay, so it may be shown here correctly or it may not be, so that is not the focus here. Okay, then similarly integer, so I told you by default you basically are having signed integer, so it's like minus 32678 to plus 32767, and we use %d as the formatter, whether we want to do printf or whether we want to do scanf. Then when you want to do short, then it is just, it gets doubled. You can see it's now 02. That means if you just double 32768, so it's from minus. Now here it is 02. That's the intention, or that's the reason we many times people will use unsigned int when they know that there is no negative number. So here the positive range increases. That means instead of just 32767, now you know it goes double. Okay, then similarly signed int, suppose if it is 4, then this is the big value. Similarly unsigned int, then long unsigned int you can have, then float and double. So obviously you can play with all these things appropriately, but the intention is, now I hope this table will help you get an idea which data type should be used, and that decides on how many bytes you really require. And when you say bytes, means actually the range in your program you require. Okay, so if for all practical purpose, say -327682 plus 32767, or say 0265535 is good enough, then you really don't require long, or you don't require even int, or say long like that. Similarly float, if it is enough, then you basically don't require double. And as you know, like for unsigned int you need to use u, percentage u. Whenever there is unsigned, then you use u, and if it is long, then you essentially make use of l, and for float you use f, and for double you use lf. That means it's a long float, or it's like a double essentially. Okay, so that's the way typically we work, or we use data types appropriately. And I hope you would have understood what exactly this video tried to convey to you, and you can play with it. You can always use this size of, and then appropriately provide the data type, and just get an idea what exactly is the size of bytes, and accordingly you can use it in your programs. I hope you like this video. Thank you.